All right, so one of the first things we talked about, okay, was actually like the history of the atom. And there's not a lot in there. What there is in the multiple choice. Okay, but have a quick read over the history of the atom, mostly in terms of structure of the atom. Okay, so that we currently accept the de Broglie model, the electron cloud, okay, that kind of stuff. You know, maybe know some of the important people. Rutherford's pretty important. Okay, he found the nucleus. Okay, Dalton is probably pretty important. The atomic theory would be important. That could be a multiple choice question for sure. Then we talked about naming compounds. Man, oh man, is that important. Because if you can't do that, you can't do mole equation, you can't do reactions, you're just cooked if you can't do naming and writing formulas for compounds. So, go over that. You've got tons of worksheets with the keys in Google Classroom. Okay, so take advantage of that. And you don't have to do a lot. Like, don't do all the, definitely don't do all of the sheets in the digital workbook. Okay, that is not necessary. It's not a good use of time. But pick a few. Okay, if you pick 10 at random and you get all 10 right, you're good. Okay. And then the next most important thing, lesson 12, writing reactions, writing and predicting the products of a chemical reaction. As I said already, you're definitely going to be asked to do that on your final exam. So know your 5 reaction types, okay? Synthesis, decomp, single replacement, double replacement, combustion, okay? Know their rules. Remember, combustion's got special balancing rules, okay? And you have a whole bunch of practice questions in your digital workbook and in the final exam review package that I posted last week, okay? And then the mole equation. Okay. Expect that there's probably going to be one mole equation question that doesn't use Avogadro's number and one that does. Okay. I mean, that's a fair assessment of what you learned. Okay. So remember, the mole equation is N equals little m over big M. Okay. Avogadro's number is on your periodic table / formula sheet, so you don't have to memorize the number itself, but you do need to know when to use it. Well, I don't know how much time we're going to have for that. Like, tomorrow I'm going to do bio and physics, so unless we have time at the end of the day today. Yeah. Okay, also for the multiple choice part, okay, know lesson 4. We did a whole lab on that, properties of compounds, things like that, because, you know, I could give you a question like you got on your unit exam, you know, like, here's the properties of a compound. It is most likely to be A, sodium chloride, B, water, C, mercury, or D, copper 2 sulfate. Okay, and you have to select which one would be most appropriate. And then solubility and the polar nature of water. Not so much for chemistry, believe it or not. The solubility part, yeah, for chemistry. Okay, because you could be asked, you know, in a reaction between these two things, which would be soluble, which product would be soluble, or, you know, is this compound soluble or not? So know your solubility chart. But the polar nature of water is really more for the bio unit. We talked about it a lot more there when we talked about how plants transport water. So definitely go over the polar nature of water. Okay, and as I said, in the written response, balance, predict balance, okay, mole calculations, right, naming. If you're going to do naming, how do you tell the difference between an ionic compound and molecular compound? Okay, well, they should all end in "ide" unless they have a polyatomic ion. But an ionic compound is going to have something in it that a molecular doesn't. Okay, there'll be prefixes in the names for a molecular compound. Yes, wasn't what I was thinking, but yes, that's right. A metal, right. Ionic compounds are a metal and a non-metal. And molecular compounds are 2 non-metals. Okay, so that's what I was leaning towards before. Okay, with the ionics, which one do we name first? Metal first, non-metal second, and then as Maddie brought up, non-metal ends in "ide." Okay, so that's important. If you're writing formulas, you got to do the drop and swap. So you got to write the charge for the metal and the non-metal, drop and swap them, reduce if necessary. What if your metal has more than one charge? Right, you gotta, yeah, balance it to figure out which Roman numeral, or use the Roman numeral to do the drop and swap. Yeah, Roman numerals anyway is what comes into play for those. For molecular compounds, write them in the order they're already written, okay? Put prefixes on them if necessary. You don't have to balance anything with those. Okay, so let's see how you do here, okay? I want the names for those 3 compounds. Actually, those 4, because now there's one of all of the kinds that you could possibly get. Okay, give you a couple minutes on that one. All right, what's Mg stand for? Magnesium. All right, so this stuff would be magnesium chloride. Okay, don't need any prefixes here. All right, for this one here, Fe2O3. What's Fe stand for? Okay. And what does O stand for? Okay, what does this name need? It needs a Roman numeral. Iron can be a 2+ or a 3+. Okay, so how do I figure out which one it is? I look at the charge on oxygen. Oxygen is always a -2. Okay, that means that there are 6 negative charges. A compound has to have an overall charge of, its positives and negatives have to add up to 0. Okay, so that means I have to get 6 positive charges from 2 irons. That means each iron has a charge of 3. 6 divided by 2 is +3. So this is iron, Roman numeral 3 oxide. I need you to pay attention. Okay. And then for this one here, okay, we've got sodium and what's CO3? Carbonates, right, it's a polyatomic ion. Okay, for that one we're done. Okay, and for the one molecular one I had over there. All right, so I've got, how many nitrogens here? 2. So what's the prefix? Di. Okay, first one doesn't get an "ide" ending, but the second one does. Trioxide. Okay, everybody okay with that? Ringing a bell? Okay, let's go the other way. Okay, let's have a look at these. So, lithium nitride, ionic or molecular? It's ionic. Lithium is a metal. Okay, so when I'm writing the formula for an ionic compound, I write the formula for the metal and its charge, +1, and nitrogen and its charge, -3, and then I drop and swap, Li3N. All right, and then magnesium oxide, same deal, Mg, it's a +2, oxygen, it's a -2. When I drop and swap, do I put the 2's down or do I cancel them off? Okay, I reduce them down, cancel them off. This already adds up to 0. So MgO is our formula for that one. Copper 2 sulfate. What does the Roman numeral tell me about copper? It's got a 2+ charge. Okay, and it's with sulfate, SO4, which is a -2. So the formula for this one would just be CuSO4. Okay. All right, and then for this one up here, triphosphorus tetrabromide, P3BR4. Ringing a bell? I think I meant to take some stuff off of here. Okay. Okay, predict and balance. This is what you're asking for. Take a little time. let's just quickly go through these so we get a chance to do a mole equation question or two as well. All right, so our first one, we have two elements reacting. What kind of reaction is that? Synthesis. Okay, in a synthesis reaction, they combine to form a single compound. Okay, in this case, that would be an ionic compound. Sodium is a metal, chlorine is a nonmetal. This is a +1, this is a -1, so that compound is okay the way I have it written. Now I need to balance the whole reaction. There are 2 chlorines on the reactant side. Now there are 2 chlorines on the product side, but there are also 2 sodiums. So I've got to go back over here, put a 2 in front of the sodium, and now my reaction is good. Okay, what kind of reaction is the second one? Combustion reaction, yeah. Okay, products of a combustion reaction are always carbon dioxide and water. Okay, in this one, I have an even number of carbons. So what do I have to do? Right, okay, I have to use the rule of 2. Okay, so I'm going to put a 2 in front of this and start my balancing. What order do I balance it? Alphabetical order. Okay, 2 times 2 is 4 carbons. 2 times 6 is 12 hydrogens. 6 times 2 is 12. All right, now I can look at my oxygens. 4 times 2 is 8. 6 times 1 is 6. That makes 14. 7 times 2 is 14. And now my reaction is balanced. Okay, those are probably the trickiest. And then for our last one here, we've got sodium oxide reacting with magnesium nitride. What kind of reaction is that? Double replacement reaction. In a double replacement reaction, we simply swap the metals. Okay, so we would have sodium now with nitrogen, and we would have magnesium now with oxygen. Since these are both ionic compounds, I need to drop and swap them. This is a -3, this is a +1, so Na3N. This is a +2, this is a -2, so that compound is good the way I wrote it. Okay, what should I balance first? Our general rule is go with the biggest number. 3 is in there twice. Which one should I do first, sodium or magnesium? I should do magnesium first because it has a bigger charge. Thus, it has a bigger effect. Okay, so I'm going to balance the magnesium first. There are 3 over here. So I'm going to go over here and put a 3 there. Okay, that gives me 3 oxygen. So I'm going to go back over here and put a 3 in front of this. That gives me how many sodium? 6. Okay, so I got to put a 2 in front of this to get 6 sodiums. That gives me 2 nitrogens. That's nice. Now there's 2 over there. Okay, and I'm done. Okay, it's balanced. Ringing a bell? Once you do a few of those, I think you'll find that you remember how to do them. You guys were pretty good at those by the time we were done the physics or the chemistry unit. Okay, and that's really the big thing, guys, is just try a few. Okay, rather than like going through the notes and doing all that kind of stuff, just try a few. If you're getting them all right, you're good. Okay, you remember how to do it, and you probably don't need to spend a whole lot more time practicing. Should you spend a little bit more? Yes. Okay, it never hurts to practice, but okay, spend the time on the things that maybe you're not as strong with. Okay, give that one a try. That's the easiest. That's the easiest mole equation question. Okay, so as with any mole equation question, okay, we write down our givens. They told us the mass, 250 grams. They told us the material, sodium sulfide. So that would be Na with S. Sulfide's a -2, sodium's a +1, so we got Na2S. So that'll be 22.99 times 2 plus 32.07. Okay, so, I don't have my calculator fired up. Someone tell me what that comes out to? 78.05 grams per mole. All right, N equals little m over big M. I have little m and big M. I'm looking for moles. Okay, 250 divided by 78.05. Okay, so 250 divided by 78.05. Okay, 3.2 moles. Okay? Everybody all right with that one? How much time do we got? We got 3 minutes. Wonder if I have another one. I do! Look at that. Okay. That one's, what's the mass? We got one with, oh, I have one with Avogadro's number. That one has Avogadro's number in it. Okay? Give that one a try. That'll give you a pretty good idea what you got on the test. Okay, so we're looking for the number of molecules of calcium chloride. So big M, CaCl2. This is a +2, that's a -1. Okay, so that's going to be 40.08 plus 35.45 times 2, which is 110.98 grams per mole. You can check my math, I'm pretty sure it's right. Okay, and we're looking at a mass of 175 grams. All right. If I want to find the number of molecules, I need the number of moles. To get the number of moles, I'm going to take the number of molecules and divide it by Avogadro's number, because that's the number of molecules in 1 mole. That'll tell me the number of moles. So, sorry, I'm looking for the number of molecules. I got to do that later. First, I got to calculate the number of moles. Okay, number of moles, little m over big M, because they told me I had 175 grams, and I got to divide that by 110.98. Nope, I forgot my numbers. 175 divided by 110.98. So, there's my number of moles, 1.576. Right? Yes. Okay, moles. Now, I'm going to use this formula here to get the number of molecules. So I'm going to take the number of moles and multiply it by the number of molecules in 1 mole, Avogadro's number. Okay, so when I do that, I take that number and I go times 6.02 E23. Okay, we are looking at 9.49 times 10 to the 23 molecules. Sorry, I had to go so fast. Are there a whole bunch of completed examples in Google Classroom? I did this 4 days in a row. Okay, I did 4 examples each day for 4 days. So there are lots of examples if you want to go back and watch those podcasts. See the question on the board, press pause, try it yourself, press play, see it done. Okay? All right. There are no bells today. See you guys. We'll do bio and physics tomorrow.